Now we are going to apply some animations to the pair. Let's create some new folders to contain the art assets of the pair, like animations and textures. I have prepared a texture for the pair. Drag it into the project. Click on that texture and make some changes to the import settings. Select multiple for sprite mode. Set 16 for pixel per unit. Select point for filter mode and none for compression. After that, click the Sprite Editor button right here. We are going to slide the texture into a sprite sheet. In the Sprite Editor, click the Slice button at the top left corner. Choose Grid by Cell Size for type. Then set 32 for pixel size. Choose Custom for pivot. Then set 0.1 for custom pivot. Lastly, click the Slice button at the bottom right corner. Alright, the texture has been sliced into multiple individual sprites. Now, get back to the hierarchy window. We have to create a new sprite renderer. Delete the original one, then right-click, 2D Object, Sprites, and select Square. Then add an animator component to that object. Apply the first sprite to the sprite renderer component of the pair. Because of the pivot of the sprite, the position of collision box is not matched with the renderer. Change the offset in Capsule Collider 2D to solve this problem. Next, we have to modify the character component for the animation related stuff. Set the fields and properties for the animator and sprite renderer. An integer called face direction. +1 means right, and -1 means left for this field. In the setter of face direction, we need to modify sprite renderer.fifx with the value. Lastly, add one more Vector2 prefix field called last position. Let's get back to the editor. Select the pair object, then assign the object reference to those fields we just created in the character component. Go to the project window, right-click on the animations folder, and create an animator controller for the pair. Select the sprite renderer of the pair, then drag it to the animator component for the controller reference. After that, we have to create several animations. First one is idle, then press Ctrl D to duplicate another one. Next is run, then mid-air, slow ascent, and fast ascent. Also slow descent and fast descent. That's all. Next step, we are going to add some parameters to the animator controller. Go to Window, Animation, Animator. Select the animator controller of the pair. Click on the Parameters tab, then the plus icon button to create a parameter. We need to create 5-fold parameters: displacement.x, displacement.y, abs, displacement.x, velocity.x, and velocity.y. Also, we need one Boolean parameter called isGrounded. Let's make some modifications to the character component. Create the fixUpdate method, which is called every 0.02 seconds by default. In this method, create a local Vector2 variable's displacement, which is equal to the rigid body 2D dot position minus the last position. We also have to update the last position at the end of this method. Next, we are going to update the value of the parameters in the animator controller, using the animator.setFold and animator.setBool. Alright, set displacement.x and y, abs displacement.x, which means the absolute value of displacement.x, then velocity.x and y, and the last one is grounded. Let's get back to the editor and have a test on it. Now the value of those parameters should be updated when you move the character. It's time to create some states for the animator controller. Right-click in the animator window, create state, then select from new branch tree. Call it onGround, which handles all the animations on the ground, including idle and run, and the other branch tree called mid-air. Double-click on the ground branch tree to edit. Select the branch tree node and choose ABS displacement.x for the parameters field. In the motion list, click on the plus icon button to add a motion field. Then drag the idle animation to that field. Add another one for the run animation. After that, uncheck the automate thresholds field and set 0.01 for idle animation and 0.03 for run animation. Let's talk about how the band tree works for 2D games. In this case, if the value of that parameter is lower than 0.02, then the animator will pay the idle animation. If it is greater than 0.02, then pay the run animation. The next one is mid-air band tree. Choose velocity.y for the parameter. Add 4 motion fields. Then drag the fast ascent, slow ascent, slow descent, and fast descent animation to those fields. For the threshold, set 2 for fast ascent, 1 for slow ascent, -1 for slow descent, and -2 for fast descent. That's it. Now get back to the base layer of the animator controller. We have to make a transition from on-ground to mid-air state. Then select it. In the condition list, click the plus icon button to create a condition. Then choose is grounded and false for this condition, which means if the parameter is grounded is false, change the state from on-ground to mid-air. We also need to uncheck the has exit time field right here and set the transition duration to 0. The next one is the transition from mid-air to on-ground state. It's almost the same as the previous one, but the condition is true. The next step is to create the keyframe animation. Go to Window, Animation, Animation, then select Sprite Renderer object of the player. For the idle animation, drag the sprite 0 to frame 0, sprite 1 to frame 60, and get back to the sprite 0 in frame 120. Now click on the play button to preview the result. It looks great. For the run animation, we are going to use sprite 2 to 9, assign them to frame 0 to frame 35, and get back to the sprite 2 in frame 39 for a loop animation. For the ascent and descent animation, assign sprite 10 to fast ascent, 11 to slow ascent, 12 to slow descent, and 13 to fast descent. All of these animations only contain a single frame. We also have to change the idle and run animation to a loop animation. Select it on the project window, then enable the loop time field right here. Let's check if it works. Great, the animation is fine, but it seems I forgot to update the face direction of the player. Go to the movement behavior graph of the player. Double-click on the run state, then add a character.face direction node at the end of the graph. Oops, we have to regenerate nodes after adding those new properties to the character component. Now add the character.face direction node again. Connect it. Then assign the massf.signed output to this node. That's all. It's time to have a final check. Excellent. Everything is done. That's all for the player movement beginner course preview. Now you are able to move around and jump with your character, build a simple level with the tile map system, and create your own 2D platformer. If you like this video, don't forget to leave a comment below and subscribe to my channel. Thank you for watching this video. See you guys.